Now, in this video, we're going to be exploring different things involving intervals, and some of you may have come across this particular term in various concepts in mathematics. And this is going to be important because sometimes different data are provided or sets and items, and how are you going to be including and excluding various items in a particular mathematical expression. And so first, before we actually dive into this, is to produce an overview of what we are going to talk about. First is you're going to explore what it means when we talk about open intervals and how this is different from closed intervals. And so once you're able to analyze various case scenarios involving open and closed intervals, we will then look at other types of possible intervals, which are 7 other intervals that are out there. And take note that we'll be using not only variables, but also we'll be using the number line. So sit back and enjoy this particular video. And so first is, what is an open interval? An open interval, in this case, we need to understand first that sometimes where you're given a specific set of all x values of which a particular property actually holds, we actually have a case scenario where a is less than b. So a is a property and b is another property, and so therefore where a is less than b, we actually have a particular open interval where we have a particular result, that is where our bracket, which is a curved bracket a and or 2b, is a set of all numbers that are between a and b, but not including a and b. So therefore, as a result of that, when showing our expression, we have our bracket, which is a curved bracket a, or numbers between a and b, close bracket, where this is expressed as x is, in this case, all set of numbers that is a less than x and less than b. And we can actually illustrate this when drawing a number line, where our number line is going to be shown as this, and where we have, in this particular case, a labeled here and b labeled here. We have our x, well, in this case, a set of all x, to be within this particular region right here, but not including a and b. So as a result of that, this here is known to be called a open interval. So that is something to keep in mind. And we can, don't forget to also show this particular expression right here. So that is what open interval is. Another example of this could be, in this case, where you have a number 2, 4, and you show a bracket, which is this particular form of curved bracket. This means that we have x to be numbers that are between 2 and 4. So 2 in this case is less than x and less than 4. And so therefore, to draw our number line, all we have to do is draw the straight line, and then we highlight our 2, which is shown right here, and we find our 4, and then we highlight the specific interval where it is true for our open set now, or open interval. So that is how to illustrate open intervals. Now the other case scenario is looking at, in this case B, we're looking at closed interval. For closed interval, what we have is it is expressed where given A and B is a really edged bracket, and that is what makes closed interval to be different from open interval, where open interval has both brackets to be curved. The closed interval has the angled edged brackets around both the two numbers where it holds. So therefore, this is going to be shown in this case where A and B are endpoints, and so that is another term to keep in mind. And this endpoint, as shown in our number line, implies that we have, in this case, a number line where we have this to be A and here to be B, and therefore what happens as a result is that from this A which is included and B that is included, all these numbers actually hold. And so this is also expressed as equal to where set of all numbers, which is X, holds where A is less than or equal to that number and less than equal to B. And so this here is illustrating what this particular number line is shown right here for closed interval. And so A is an endpoint and B is an endpoint. However, for open interval, 2 and 4 are not endpoints because they are not included in this particular interval here. And so that is how you're able to compare closed intervals and open intervals. Now, the other 7 intervals that we're going to show in this particular video are as follows. First is where you have A and B, and on one end it is an endpoint and the other one is not an endpoint. And so what that implies is that we have all sets of numbers or values that is where A is, since in here we have our curved bracket which is right before A, it means that A is not included and therefore it is less than, but not equal to, yes, of course, less than X, and X is less than or equal to, because the B comes before the bracket with the edged sides. In this case here is going to be less than or equal to B. So therefore, in this case, as we are going to show in or on our number line, we can see that yes, when we draw our number line, we know or locate our A and B regions. What we figured out is that where A is less than X, that means that it is not an endpoint. So we have our circle with a hole in there, and while where X is less than or equal to B, that is an endpoint because B is included. And so therefore this region here is true for this particular expression. So this is number 1. Now the next one here is what if you're given the edge to be A as the bracket, and this is at the other end to be B with a curved bracket. That means, of course, that if you try this without me actually showing the solution, if you want to pause the video, you can try it out, but you should figure out that it is, in this case, X, or which is all set of X, where A is less than or equal to X and X is less than B. Therefore, B is not an endpoint, but A is an endpoint. and that is rightly represented by this particular notation as shown for 2. Now, next one here is looking at the case scenario where you have a curved bracket A, comma, this particular symbol right here, and you have a curved bracket. What does this particular symbol here mean? Some of you may have come across it on some of your classes, but it means positive infinity, which is any positive values that is on the far right of our number line. So that means in this case that when showing our specific outcome, it shows our specific regions on the number line. In this case, where our set of x is where, in this case, A is what? A is always, in this case, less than x. So it means that in this case, all the numbers of x, or all the set of numbers, are greater than A. And so therefore, showing this on the number line, we are going to have our first introduction to a specific different type of line. And this introduction, after showing our number line, and we figure out where our A is in this case showing that, hey, since A is not included because it is a curved bracket, we are going to have our donut first, and all numbers in this case that are x, it means that it is greater than A. Therefore, we are not going to the left, but we are going to the right of our number line. And this actually shows you that, yes, I'm going to positive infinity. Now, that is really cool to see. We can actually have another inclusion here, which leads to 4. And 4 here is where you have your sharp bracket with your A, and you have your positive infinity with a curved bracket. In this case here, we have our x to be where all numbers, in this case as A, is less than or equal to x. Therefore, in this case, what we figured is that our notation is kind of similar to the previous example, or based on the specific number line. But there is a catch. The catch is that we have our dot, which means that A is included. A is an endpoint, and numbers that come after A from the right or to the right, infinity, positive, is actually shown or expressed as question or case number 4. So what you notice here is that for case 3 and case 4, while our A has a bracket that is either curved, which shows that A is not included, or sharp bracket, which means that A is included, our infinity shows that, hey, it is always curved. And in this case here, when you're going to infinity, it is really impossible to figure out what the last number on the right side is. Well, I mean, what number do you think comes after 1,000, 1 million, 10 billion? All those big, huge numbers, it just keeps on going and going. So there is no end point. So the arrow continues to positive infinity. So that is something to keep in mind in here. Now, the other 3 are as follows, and they all relate to each other in some capacity. And so in here we have 5 or 5th case scenario where you have a curved bracket, and now we have our first negative infinity, and we are going to be with our specific bracket curved. So from our case 3 and 4, you should be able to figure this out, where x is all numbers, where x in this case all numbers are less than b. And so therefore, when you draw this, you should be able to illustrate it without me actually showing you. So I guess you guys are going to beat me to this one. And therefore, where we figure out our B position, we know that it is not included because the less than sign doesn't have an equal sign, and therefore you are going to the left because the regions are all numbers less than B. And so the other case, second scenario, is looking at where our particular curve bracket and then negative infinity, and this is the other point, which is B, and this is shown as the sharp bracket. And so therefore this is shown in this case as all numbers or all real numbers where the numbers here are less than or equal to, because of this sharp bracket that comes after B, is equal to, or well, less than or equal to B. And so therefore, by showing this on our number line, you should be able to figure out that it is similar but opposite to that of our case number 4 that is shown right here. Therefore, we are having our B to be included, and B is equal to greater than all numbers that are at 8 or towards 8. So therefore, that is our case number 6. And finally, here is our case number 7 to round off our particular video. And so therefore, our case number 7 shows that, hey, what if you have a curved bracket with a negative infinity and you have a positive infinity with a curved bracket? What does this tell you? This tells you that, hey, we are including all numbers on the number line. In this case, these are indeed sets of real numbers. Real numbers, remember, in this case, these are numbers that are either, in this case, you have rational or irrational numbers, and that is what you're including in here. And when you talk about rational numbers, we have numbers that can be expressed as P over Q, which are integers, or including integers. I mean, you can also include integers here as well. Real numbers, you can include integers. Let's put that into the integer right there. And in this case here, for irrational numbers, we can't express this as P over Q. Examples of this includes the following. We have pi, we have e. In this case here, we have any square root of a number that won't give you square root of 2, won't give you an integer, but to give you like a decimal. Anyways, all those are many things to keep in mind in here when it comes to irrational and how is that different from rational numbers. But all this here, irrational, rational, integers, positive or negatives, they are all real numbers that exist on the number line. And speaking of the number line, you'll be able to show that, hey, we don't need to do anything. Well, you just have to show arrows on both ends with the head, and then you just draw a line, and voila, there we have it. And so these notations are, in this case, easy to remember. Just know when to use the brackets and know when the ones that are endpoints and the ones that are not endpoints based on the type of brackets that you actually have. So that's about it for this particular video. I hope you're able to understand or explore this. You'll be able to apply this anywhere in your specific relationships in terms of functions, or also in terms of solving inequalities. And this is a skill that is going to be beneficial for you on the long run. So all the same, please hit the comment down below. Let me hear your thoughts about this and many more. By that way, I can talk to you all soon. Stay smart as always and believe in yourselves.